In this talk, we're going to discuss the distance methods to infer phylogenetic trees. Another popular phylogenetic inference methods are the distance methods. These methods build a tree based on distance data between sequences. In some way, they apply a similar philosophy to the progressive methods for multiple sequence alignment. There are two principal distance methods: the UPGMA, unweighted pair group method with arithmetic mean, and the neighbor joining method. The UPGMA method builds a tree by a sequential clustering methods which consists in several steps. First, you have to build a distance matrix from the sequence alignment. Then, given this matrix of distance, start by grouping the two taxa with the small distance. Place an interior node at the midpoint between them and create a new matrix by considering this group as a single taxon. Then you build a new distance matrix taking into account this new taxon as the combination of the two previous joined together, and repeat the same grouping process until all taxa are placed on the tree. Let's take an example of how it works in practice. Suppose that you have an alignment of 5 DNA sequences and you construct a distance matrix that represent the relationship between them. Then you start by grouping the two taxa with the smallest distance. The branch length connection between these two taxa is half the distance between them. Now you recalculate the distance matrix using this time a taxon composed by the two previous clustering elements. Now, instead of this matrix, we construct this reduced matrix, and these two are joined together. The distance between each taxa and the composed taxon, AC, is calculated as the average of the original distance from that taxa to A and C respectively. The same for this and D with B is the same value. Once again, you choose the small value of the new distance matrix. This is the small value, and group the taxa with the small value, in this case B, with AC. Thus, a new cluster BAC is formed. Same as in the step 2, the length of the branch is half the distance between B and AC. Now, you repeat the process, but this time the new distance matrix is composed of only two entries, D and the cluster formed by B, A, and C. Calculate the distance as the average between the new taxa and you have the B, the A, the C, and you have a new distance. And cluster D with the rest of other taxa using the branch length half the distance between D and the rest of the taxa. In this way, you have calculated a phylogenetic tree using the UPGMA approach. This is another example of the UPGMA method with the details of the step used in the method for you to study. Major problem of this method is that generate ultrameric trees in which all taxa are separated from the same distance from the root tree. All are at the same distance. This happens because the method employs a constant molecular clock hypothesis, which means that the rate of evolutionary change of any specific taxon is approximately constant over time and over different lineages, which in some cases is not true. There could be taxa that could evolve at different rates during the time. To overcome this problem, the neighbor joining method is employed. Neighbor joining takes as input a distance matrix specifying the distances between each pair of taxa, same as the UPGMA method, but it allows unequal rates of evolution in different branches of the tree. Let's see how it works. This method starts with the construction of a star-like tree, and a star-like tree with all taxa included. Then, for each taxon, we calculate a measure of the distance between that taxon and every other taxa. Later, identify the pair of taxa with the minimum value according to this formula. This means the distance between the two taxa, and these are the distance or the average distance from the rest of the taxa we want to calculate. And join the taxa with the minimal distance in one node similar as the UPGMA method. For the calculation of branch length, unlike the UPGMA method, neighbor joining does not force the branch lengths to be equal. Instead, these distances are calculated according to the following formulas. In this case, we calculate a new distance matrix with the two merged taxa replaced by a node that joins them, and calculate the distance from this node to the other taxa according to this. We repeat this process until all taxa are added to the tree. Here we have an schema of how the neighbor joining method works. We have the distance matrix here, and we calculate the distance of each node to every other node. For instance, for the A, we have distance to B, distance to C, and so on. And then we divide by 4. Similar for B, C, D, F, A, and E. These are like average distance from one taxa to the rest of other. Then we calculate the pair with the small m according to this, which means the distance between each of taxa minus the distance from separating each one of them to the rest of the taxa. In this case, the smaller are between A and B, 5, that is the actual distance between them, minus the is A and is B. This also occurs for these two nodes, D and E. Here we choose the AB and cluster together. When we cluster, we create a new node that in this case we call U, that joins A and B, but in this case the branch length is calculated according to this formula. It has to do with the distance, the real distance between them, and an average of the distance between each of them to the rest of the node. As you can see, this is not symmetric. Now, we put in our matrix the new node, which includes A and B, and calculate a new distance matrix with all the values, and then repeat the process until we complete the tree.